Hey, what's up guys? Today let's look at the Lintcode problem number 14, first position of target. Description. For a given sorted array, ascending order, and the target number, and find the first index of this number in O log n time complexity. If the target number does not exist in the array, then we return -1. For example, if the array is this, and for a given number target 3, and we return 2. In this array, we found 2 of target, right? We return just the first one. Return the first index of this target. So that's why 0, 1, 2 will return 2. This is typically a binary search problem. So how do we do this? Obviously, we're going to just use binary search. And in generally speaking, the binary search strategy is that we have the left pointer, we have a right pointer, and we calculate the middle pointer. And we calculate the middle element with our target, and depends on the relationships between the target and this middle elements, and we decided to go left or to go right. So every time we can cut half of the solution spaces, and we just search the solutions in half of the solutions. Every time we cut half. So that's why our total time complexity is O log n. So let's look at the code for detail. First part, we're going to do the input parameter checking. If the array is empty or none, we just return -1. And then we just initialize our left and right pointer, or start and end pointer. The leftmost is 0, position 0. The rightmost is length of the nums -1. And we use a while loop to continue searching the target in this array. And the condition is that the start plus 1 less than end, and we're going to just continue this while loop. And within this while loop, we calculate the middle elements, middle position of this array. The way we do it is start plus n minus start minus 2 divided by 2. Some people probably will do this like middle equals to a start plus n minus 2. Actually, they are the same. The only difference is that when you do a start plus end, it may overflow if you just use an integer, because integer has a limited scope, has a limitation. If the number is too large, you may face the overflow. So if you use this one like n minus start and then divided by 2, it's more safer. You won't have that overflow issue. If you can specify this to your interviewer, they will give you a good rating about this knowledge. All right. Once we calculate the middle position of the element, we calculate that the middle element, compare this middle element with our target. If the middle element rate equals to our target, then we're gonna just cut the right half of the solution. So we update this end position, assign as mid to this end. Otherwise, we just cut the left half of the solution. So this is the whole while logic. It is pretty important. And also let's understand this further. Start plus 1 less than n. That means what? It means we have to have at least 3 elements to to execute this part of logic. If we were given an array, and this array does not have does not have at least 3 elements, it has 2 or less elements, so we don't execute this part. We just do this judgment separately. If the start equals to our target, we just return start, because in our problem we need to return the first index of this number. So that's why here for the if, we just judge the start first. If start does not equals to target, so we just judge the end. If the numbers end equals to target, we just return. If both not, and we didn't found it in a while, so we just return -1. This is a template. In the binary search field, there are so many different mutant problems. Sometimes it can becomes really complicated. So if you just write using this template, it's gonna be much better. You don't have a lot of like a boundary issue. Sometimes you don't know if you should put the equals or not. Sometimes you probably think, should I just put like a start less than n or less equals to n? No worries about that. It's just always use this one start plus one less than n, and to do this while loop, and here you write another two ifs to judge the end, the start and end separately. It's gonna make it more simpler and safer. So let's run this. Looks great. Yeah. So thanks. That's today's algorithm.